This is our third video on section 6.6, the Pythagorean theorem. We're going to show you a quicker way to do all of your operations at once. You're not going to have to work it all out by hand. If you have a right triangle and you know two of the sides, if both of the sides that are given are legs, then what you do is you take them and you square them and you add them, then you take the square root. So it's really easy. If you want the hypotenuse, you take the square root of your two numbers squared and added. Now, you can type this directly into your calculator, and that's what I'm going to do. We're doing square root of 11 squared plus 5 squared. And that's going to give you an answer. I'm going to keep two decimal places. It's telling me the answer is 12.083. And I'm just going to use a 0 and an 8 because the 3 is not 5 or bigger. Does this answer make sense? This is the hypotenuse now, 12.08. It's bigger than 11 and 5, so that makes sense. When you have the legs, put an addition sign here. When you have a right triangle, they're not always going to give you the two legs. Sometimes they give you a hypotenuse and a leg. So if you want the other leg, let's just call it A, for instance. You're going to do the same thing you did over here, except you're not going to add the two numbers. You're going to subtract them. And here's another very important detail. If you're going to subtract two numbers, you better have the bigger number first. Otherwise, you're going to get a negative. And you can't have a negative under this radical. So make sure this is a minus. When you have the two legs, add. When you have a leg and a hypotenuse, subtract. So I'm going to type that into the calculator again. Square root 34 squared minus 17 squared. That's going to give me 29.444. I'm going to keep two digits, just like money. I want the nearest hundredth. I'm just going to leave it as 29.44. Does this make sense? Well, it's a leg, so it better be less than your hypotenuse. Keep this in mind. This will save you a lot of time. When you have the legs, add. When you have a leg and a hypotenuse, subtract. So here's two examples. You have a right triangle. You have a leg and a hypotenuse. You better subtract. Here's an example. You have a right triangle. You have both legs. So you're going to add. So in this one, we'll call this A. To find A, square both of your numbers, subtract them, make sure the bigger one's first, and take the square root. I'm going to type this in. So I type in my square root of 65 squared minus 33 squared. And this gives me a whole number answer, which is kind of rare, but they tell me that it's 56. That makes sense to me because it's less than my hypotenuse. Now on this one, if I have both legs, I'm going to add. I want the hypotenuse. So I'm going to take both of my numbers, and it doesn't matter if you put the bigger one first or not. I'm just doing it because I had to do it over here, so I'll just be consistent. It'll give you the same answer either way when you add them. Take both of your numbers squared, add them, and take the square root. Take a second and type that in. It gives me 89. And that makes sense because that's the hypotenuse. It better be bigger than both of your legs or either of your legs. Let's try. We have a hypotenuse and a leg. Subtract. We have a leg and a leg. Add. Since I'm subtracting, I'm going to put the big number first, little number second. I'm going to take a second and type it in. Square root 37 squared minus 12 squared. That gives me 35. Again, it's a whole number answer. 35 is less than 37, so this makes sense. Sounds good to me. We have both legs here. We want that hypotenuse. We're going to take the legs and square them. We're going to add them, then take the square root. I'll type it in. Square root 60 squared plus 11 squared. That gives me 61. And 61, it's exactly 61. It's bigger than 60, so that makes sense as an answer. Notice how we said in the last video that you're not going to get whole number answers a lot, and you aren't, but we just got whole number answers on these last two. When you have side lengths that are whole numbers, all three of them, these are called Pythagorean triples. And we're going to talk about Pythagorean triples as we go, because Pythagorean triples can save you a lot of time. For example, the next time you see a problem like this, where you know one leg is 11 and one leg is 60, you're always going to know that the hypotenuse is 61. Also, if you ever see this problem again where the hypotenuse is 61 and maybe a leg is 11, you know that the other leg is 60.